All right, section 2.6, ladies and gentlemen, is our last section in this chapter. So again, we're going to have our practice test here in a couple days. So let's talk about the last one here. So theorem 2.3 is the right angles congruence theorem, which states that all right angles are congruent. So now we're going to prove that. So since I didn't put in a 2-column proof here, you need to put one in yourself. So go ahead, and it doesn't have to be perfect here, people, because mine definitely aren't. And instead of putting statements and reasons, I just usually put an S and an R. That's when I have to do it myself. Again, most of the time you'll be dragging and dropping it. But again, let's see here. So I told you that the first one should always be what you're given. So we're given that AB is perpendicular to line segment BC, and that AD is perpendicular to BC, and a reason for that is given. Notice how I put a 1 in the statements column and 1 in the reasons column. Again, that should just make sense. All right, so it says AB is perpendicular to BC. So it's in this one right here and this one right here. Well, if you notice, it does have a little box there. So I know that those are right angles. And then they told us, let's see, AD and DC. And again, if you notice, there's another square there. So again, that should tell us that those are also perpendicular, which makes them right angles. All right. What did I just say? Oh, hey, those are right angles. So if we look at it, since it's by itself, okay, it's not being with another line there or anything. So I can say angle B, and same here, I can say angle D. So I'm going to say then that angle B and angle D are right angles. And what is our reason for that? Well, we just said that they were perpendicular, and we know by definition of perpendicular that they are right angles. So we're going to say by definition of perpendicular lines. All right, so now remember yesterday I said if we can say is or are, usually our next reason will be by definition. Okay? And now since we just stated that they are right angles, we can state then that they are congruent to each other by the above theorem, which we were just trying to prove. So all right angles are congruent. And we're done with that one. Okay? All right, so we have a couple more theorems here, and then we're going to prove them. And hopefully this will be a quick one for you. So if two angles are supplementary to the same angle or to congruent angles, then they are congruent. So on this one here, we're saying that angle 1 and angle 2 are supplementary. We're not putting them together, but we know that if they're supplementary, they equal 180 degrees. And we know that angle 2 and 3, so these ones right here, are also supplementary. And if you think about it, so if two angles are supplementary to the same angle, so these two are supplementary to angle 2, then that means that angle 1 is congruent to angle 3. That's the congruent supplements theorem. So the other one states the same. So the congruent complements theorem, if two angles are complementary to the same angle or to congruent angles, then they are congruent. So again, on this one here, same deal. If 4 and 5 are complementary, that means that they add up to 90 degrees. And 5 and 6 are complementary. That means that they add up to 90 degrees. Again, these two kind of go together, and then these two kind of go together. So if we subtracted that angle 5 there, we would then get that angle 4 is congruent to angle 6. So that's what those two theorems are stating. And hey, let's use one of them and prove it. So we're going to say that angle 1 and angle 2 are supplementary. So these two are supplementary. Well, now if you think about it, that makes sense because they are a linear pair. All right, and I'm told that angle 1 here and angle 3 are supplementary. It's not as evident as angle 1 and 2 are, but again, since I told you that they're supplementary, you know that they are, and you know that they add up to 180. And our proof this time is we want to prove that angle 2. We want to prove that this angle and this angle are the same. Now, excuse me. Once we do that, we're going to find out there's an easier way in chapter 3. But once we prove they're supplementary, then we'll be able to see this. All right? So again, same thing like I just did before. We're going to make two columns. And we are going to name one of them statements and one of them reasons. And let's see, we are going to go ahead and state, now remember, you can do both of the givens at any time. A lot of times it makes sense to kind of go in order and then you can see it. So angle 1 and angle 2 are supplementary. I better write the whole thing for it. And the reason for that is given. So again, if they are supplementary, here's that key word again. What does it mean when two are supplementary? It means that their measures are equal to 180 degrees. So we're going to say the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And I just gave you a big hint there when I see the word are or is, right? I see are right here. That's going to be by definition. So definition of supplementary angles. And right now, since I wrote it out the whole time there, I'm just going to put sup angles there. That means by supplementary. All right. Now, can I do anything else right here? You would say, well, I can't prove anything yet, so I better use my next given. So I'm going to use my next given here. And I'm going to state that angle 1 and angle 3 are supplementary. This time I'm just going to write sup there. Again, this is our second given. Look it up there. It did say it was given. All right. So now I'm going to say same thing. If we know that they are supplementary, then we know that their measures are equal to 180 degrees. And what is our reason again? By definition. All right, now I just wanted to go ahead and show you that because we can then say, since they both equal 180 degrees, all right, they both equal 180 degrees, right? So since the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and the measure of angle 1 and the measure of angle 3 equals 180 degrees, can I just substitute in one of those? So I can state then that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 3. And what did I just do there? I just told you I just substituted, right? So I use the substitution property. And then for 6, just think, what's my goal here? My goal is to prove that they are congruent. All right. So if I subtract the measure angle 1 on both sides here, so again, look here, I have angle 1 here and angle 1 here. If I subtract them, when I get that the measure angle 2 is equal to the measure of angle 3, and again, that was by the subtraction property. And what we just learned earlier is if their measures are equal, then we know they are congruent. So I can state that angle 2 is congruent to angle 3, which is what we wanted to prove there. And again, that would be, and sometimes you see the word, sometimes you don't. But then I just say that angle 2 is congruent, is being a key word there. So that should tell us it's by definition of congruent angles. So pretty straightforward proof there. Again, I think we're going to go ahead and look at some more here later on, probably after this, since we have a kind of a day in between these two, I think it'll be good for us. All right, then we have another postulate, the linear pair postulate. If two angles form a linear pair, then they are supplementary. So the example here they give you, angle 1 and angle 2 form a linear pair. So since they're a linear pair, again, we know that they make a straight angle. If they make a straight angle, then that means that they're supplementary. And if they're supplementary, that means that they're measures. So the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And then our next theorem, theorem 2.6, is vertical angles congruence theorem, which states that vertical angles are congruent. Now remember, vertical angles are opposite each other. So I have angle 1 there and I have angle 3 there. And we know that they're congruent. And then my other one here is angle 2 and angle 4. They're both vertical angles also, and they are congruent. So remember, if they're congruent, then we know that their measures are equal. All right, so we have two quick examples here, and then we'll be done. So use a diagram and the given angle measure to find the other three angle measures, Measure of angle 3, is equal to 128 degrees. So if you notice here, I was just kind of getting ahead of myself there. Measure of angle 1 is equal to 128 degrees because the measure of angle 3 is equal to 128 degrees because they are vertical angles. So the measure of angle 1 is equal to 128 degrees. Okay. Now our next one would be, let's see. Well, if this one's here's 128 degrees, and this one here's 128 degrees. Now remember, they're going to form a linear pair. So if we think about it, these two right here form a linear pair, which makes them supplementary. So we can say that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. We know that the measure of angle 1 from what we just said was 128 degrees plus the measure of angle 2 is equal to 180 degrees. Subtracting 128 from both sides, that will give us that the measure of angle 2 is equal to 180 minus 128 is 52, right? 52 degrees. And of course, if angle 2 is 52 degrees, then we know that the measure of angle 4 is also 52 degrees because they are vertical angles. So we can say, let me write that in a little nicer. So we can say that the measure of angle 4 is also equal to 52 degrees. pretty nice and straightforward there, people. I hope you're realizing this. We will be doing a lot with angles in the next chapter. And then finally, find the value of x. Well, we know that this angle here and this angle here are vertical angles. We just said that vertical angles are congruent or equal in measure. So I can say that 4x minus 3 is equal to 101 degrees. I'm going to add 3 to both sides. So I'll get that 4x is equal to 104. And now I'm going to divide both sides by 4. And I'll get that x is equal to 26. In this case here, that's what they asked us to do. So we're all done. And hopefully this was nice and easy for you. And you can do your homework. Thank you.